Blockchain networks rely on consensus mechanisms to function effectively, ensuring decentralization, security, and trust. These mechanisms are the foundation of blockchain, enabling participants to agree on the state of the network without relying on a central authority. Let's explore 10 key consensus mechanisms and their unique roles in blockchain technology. Proof of work, POW. Proof of work is one of the earliest and most well-known consensus mechanisms. It requires participants known as miners to solve complex mathematical problems using their computer's processing power. When a miner successfully solves a task, a new block is added to the blockchain, and the miner earns a token reward, such as Bitcoin. While POW ensures strong security, it consumes significant energy due to the intensive computational work involved. Proof of stake, POS. Proof of stake eliminates the need for mining. Instead, participants validate transactions based on the number of tokens they stake as collateral. The more tokens a user stakes, the higher their chances of validating a block. POS is far more energy efficient than POW and promotes a sustainable approach to blockchain consensus. Proof of activity, POA. Proof of activity combines elements of POW and POS. Miners first solve computational puzzles to create empty blocks, but the final validation comes from stakers who add transaction data. This hybrid approach enhances security by reducing the likelihood of a 51% attack, as it's difficult to predict which validators will sign each block. Proof of authority, POA. Proof of authority relies on reputation rather than computational power or token ownership. Validators are pre-approved participants in the network who risk their reputation to validate transactions. This model works well for private or consortium blockchains where trust among validators is critical. Proof of burn, POB. In proof of burn, participants intentionally destroy or burn tokens to gain the right to mine new blocks. Burning tokens reduces their supply, creating scarcity while securing the network. The more tokens burned, the higher the chance of being selected as a block validator. Proof of capacity, POC, proof of space, POSpace. This mechanism determines mining rights based on a participant's available storage space. The more disk space a miner allocates, the better their chances of matching the required hash and earning rewards. POC offers a more eco-friendly alternative to POW by reducing energy consumption. Proof of contribution, POC POCO. Proof of contribution evaluates the contributions of active nodes in the network, such as computational tasks or storage. Each action is assigned a trust value, ensuring fairness and rewarding participants for their active role in maintaining the network. Proof of history, POH. Proof of history provides a timestamp for every event in the blockchain, enabling accurate sequencing of transactions. Each validator maintains an internal clock and uses cryptographic proofs to record events efficiently. This method enhances speed and scalability as seen in the Solana blockchain. Proof of importance, POI. Proof of importance expands on proof of stake by considering factors beyond token ownership. It evaluates a node's activity and contribution to the network, such as transaction frequency, to determine its eligibility for validating new blocks. This approach ensures a more holistic and equitable system. Proof of storage, post-storage, proof of replication, POREP, and proof of spacetime, post-spacetime. These mechanisms rely on data rather than financial stakes. Nodes are rewarded based on the amount of data they store, replicate, or provide to the network. This is particularly useful for decentralized storage solutions like Filecoin. Why consensus mechanisms matter? Consensus mechanisms are vital to blockchain operations. They ensure decentralization, allowing the network to operate without central control. Security, preventing fraud, double spending, and malicious attacks. Consistency, synchronizing data across multiple nodes. Trust, replacing third-party intermediaries with cryptographic assurances. Incentives, encouraging participation through rewards. Adaptability, tailoring mechanisms to specific needs such as performance or energy efficiency. Innovation, driving new methods to address limitations of existing systems. Together, these mechanisms form the backbone of blockchain technology, ensuring its integrity, functionality, and adaptability across various use cases.